All right, so what we're going to do today is we're going to talk about confidence intervals. So have your calculator handy, and it doesn't matter if you have a TI-83 or a TI-84. The options we're going to use are exactly the same with the calculator. So have that handy. When you log into the classroom, what you'll notice is I've opened up the following 2 weeks of lecture. What this week talks about, the lectures on 414 and 416, what they talk about is confidence intervals for a mean, so a confidence interval for an average. I will explain that. And then what next week talks about is confidence intervals for a proportion. If you click on, when you're in the classroom, when you click on the lectures for 421 and 423, you'll see that your next quiz is due. And actually, after you watch some of the videos in class, you can submit this early. You can submit it as early as you want. It's super straightforward, and I'm going to show you all the calculator options that you're going to need for this today. Okay? So what my lecture today is going to be is just going to be an application. I'm just going to show you how to do an application of confidence intervals, and I'm going to very, very briefly explain the concept to you. So when you click on when you go back to the lectures for this week, I go into a lot more detail about confidence intervals in some of my lectures in the classroom. So you should definitely watch these to fill in everything that I'm talking about in our Zoom meeting today, okay? All right, before I get started with the lecture, any questions about the quiz that's due in 2 weeks or confidence intervals in general before I get started? Okay. All right, so I have 2 examples, and don't worry about writing these problems down as I go through them. Just maybe jot some notes down of how I solve the problems, but I'm going to post this PowerPoint slide to the classroom too right after class, okay? So here's the first problem. An economist wants to estimate the mean commute times of residents in Morristown, New Jersey. Okay, so I just made this problem up, okay? And I don't know if you guys remember, but I live in Morristown, New Jersey. So this economist wants to estimate the average commute time for all the residents, okay? So what this economist does, what she does is she collects a sample of 30 individuals, right, and finds that the mean commute time for those 30 individuals is 28.5 minutes with a standard deviation of 15.7 minutes, okay? So just what she found here is she found our sample size, lowercase n is equal to 30 residents. And what she also found was that the average of those 30 residents, X bar, was 28.5 minutes. Okay, now here's what she wants to do, this economist. She wants to estimate the mean commute time of all residents in Morristown, New Jersey. So do you think the mean commute time of all residents in Morristown, New Jersey is exactly 28.5 minutes?
No.
No way. There's like no way it's exactly 28.5 minutes, okay? So this is what we call a point estimate, okay? And all a point estimate is in statistics is it's a single value estimate. That's all it is, all right? So we know it's not exactly 28.5 minutes. It's probably pretty close to 28.5 minutes, but it's not exactly 28.5 minutes. So what statisticians have thought about is like, okay, well, if it's not exactly 28.5 minutes, what is the actual mean commute time for all residents of Morristown, New Jersey? So here's the thing. There's actually no way they can figure this out, all right? The only way they could literally figure it out is to talk to every single person who lives in Morristown, New Jersey, okay? And Morristown, New Jersey, my hometown, has about 20,000 residents in it. So there's no way they can talk to all 20,000 residents. So what they do is they introduce in statistics something called an interval estimate, okay? And all an interval estimate is it's a range of values used to estimate a parameter, okay? So like a population mean. So the way we do them is we construct what are called confidence intervals, okay? And what these confidence intervals are, you're going to notice as you go through the lecture, there's going to be these things called 90, 95, and 99% confidence intervals. And all they are is saying, look, I am whatever level, 90, 95, 99% confident that the mean value of Morristown residents is between this number and this number. Okay, so let me show you how to find with your calculator these interval estimates, okay? Does everybody have their graphing calculator handy with them? If not, just definitely pay attention, okay, with this. All right, so the option we're going to use this week and going forward for the rest of the class is we're gonna click the stat button. So on your calculator, click the stat button. And then you're gonna scroll over until you see this thing called tests. Okay. Now, if you look here, what I wanted to calculate was an interval, okay? Look at the screen here. Are there any options that say interval on my calculator?
7 and 8.
7 and 8.
7 and 8 at the bottom.
Yeah, what we want is, for this is important. For this class here, you'll learn about this more when you watch the videos, is you want the option that's called T interval, okay? T interval. So in calc, we pressed the stat button. We went over to tests. We want this thing always called T interval. Always, 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 okay? You're gonna scroll down to T interval. You're gonna hit enter. And you're gonna see two options here, okay? For this example here, what the option data means is it means if you have the actual data plugged into your calculator. So when you watch the videos that I've done in class this week, I show you an example with data. But when you're given the summary statistics, okay, like the sample size, the mean, and the standard deviation, when you're just given those, you're gonna scroll over till you see stats, and you're gonna hit enter, okay? Now what you have to do is you have to scroll down, X bar. You're gonna put in this 28.5.
Uh-oh.
I'm sorry, say that again. Did somebody have a question? Okay. Does anybody remember what S stands for in statistics?
Standard deviation.
Yep, and notice in the problem I give it to you, it's 15.7. N represents the sample size. So the sample size here is 30. And this is important, this next option. C level stands for the level of confidence you want. The calculator will always default to 0.95. So I have 0.95 here. I'll show you how to change it in the next example. So you're just gonna go down to calculate and you're gonna hit enter. And your calculator takes a second. But how many people see this right here on their calculator? You can put it in the
I
chat.
do.
Yeah, I see it. I think somebody has to mute their microphone.
Yeah. Somebody is definitely getting a little bit of reverb. So if you're not talking or if you have background noise, just definitely please mute your mic, okay? All right, so what this is saying here, this top part up here, this is my confidence interval. Okay, so let me just put it in here and I'll explain it, okay? So I'll go out 2 decimal places. So this is 23.64 to 34.36, okay? And this is in terms of minutes. So here's what confidence intervals are saying. Look, I have no idea what the real mean is for all residents of Morristown, New Jersey. But based on this sample, we are 95% confident the mean commute time for Morristown residents is between 22.64 minutes and 34.36 minutes.
So you round every time though.
Yeah, the problem when like your quiz will tell you how many decimal places to round it to.
Okay, thank you.
So that's all. Go on ahead. Someone had a question?
Yeah. So when we're doing it on the quiz, like to show our work, are we gonna write like T interval and then the numbers? And then
This is exactly what you would write right here. What I just highlighted. Okay, so when you see, and I'll go to the quiz here, so you can see the directions say, you know, I use the t-interval option to estimate a 95% confidence interval, and it was this. Okay.
You don't write the in-calc test thing, like how you do it though. You don't.
I will accept either. I just generally want to see somewhere that you used what option you used.
Okay.
Okay. Does that make sense with everybody?
Yeah.
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 Okay. All right. So that's one example. Okay. So this week in the videos, you're going to get into more detail about confidence intervals for a mean. Okay. And this is an important lesson that I just want to highlight in statistics. Just because somebody took a sample and they got the mean to be 28.5, okay, that's just from a sample of 30. So what we're saying is, look, based on this sample, it's really plausible that the mean commute time could be as low as 22.64 minutes or as high all the way up to 34.36 minutes, and everything in between. It's somewhere in there, okay? That's what these confidence intervals are saying. All right, let's do another one, a little bit different, okay? So next week, what you're gonna learn about in this week and next week in 421 and 423 lectures in a little bit more detail is expanding this confidence interval to talk about proportions, okay? So this was actually a survey that roughly came out last week. It was all over the news. Okay. Is anybody really sad about missing sports right now?
Me. I have nothing. I just play video games. That's it.
I am incredibly sad about missing baseball myself. Okay. I'm a big Yankees fan, missing that. Last week I was supposed to be in St. Louis for 2 baseball games. Was really sad about that. So this survey came out that I was kind of interested in. So in a recent survey of 1,000 adult Americans, okay, they were asked, would you attend a baseball game before a vaccine was available for COVID-19? Okay. And what they said, 300 of the people said they would attend a baseball game before the vaccine. Okay. So what I want to do here is construct and interpret what's called a 99% confidence interval for the proportion of adult Americans who would attend a baseball game before vaccine. All right, so from this poll that came out, okay, we can introduce, you learned about this p hat last week. It's just the sample proportion. That's just equal to x divided by n. So you take the 300 people who said they would attend a baseball game, divide it by the 1,000 people in the sample. And what we're saying here is that 30% of adult Americans said they would attend a baseball game without a vaccine, okay? So now here's the whole reason you need confidence intervals. Do you think it is exactly 30% of adults who will attend a baseball game before a vaccine comes out?
No, because it's
not
only
possible.
1,000 individuals.
Yeah, it's only
Yeah.
1,000.
Oh, it's already 1,000. Yeah. I was. Yeah.
So this is that point estimate again, okay? That this is a single value estimate for the proportion of people who will attend a baseball game before a vaccine. But what is the real value? Okay, like again, the whole point is I can't talk to every adult American and ask them if they'll attend a baseball game before a vaccine. So I have to estimate it now with a range estimate. And this is just a confidence interval. Okay. So to go back to figure out what this confidence interval is, okay, you're gonna press the stat button on your calculator. You're gonna scroll over to tests, okay? And this is important. You're gonna scroll down now. Until you see this option, okay? It's 1-prop Z interval, okay? So we went stat, so in calculator. We went stat, and then you're always, for these, you're gonna use 1-prop Z int, always, okay? So notice the difference in the options that you pick, okay? That's why it's really important in your calculator to tell me what you're picking, or in your note, in your solutions for quizzes and stuff. So 1-prop Z int, here and just hit enter. Okay. And you're going to notice, unlike the previous example, there is no like data versus stats. It just says, okay, what's your X? Well, that's the number of people who said they'd attend the baseball game, 300. N is the 1,000 people. So I'm going to do 1,000. And now this is important. The confidence level it always defaults to is 0.95. Just for reference, in industry, you know, outside of the classroom, when people do confidence intervals, 95% confidence intervals is like always the default standard. So that's why your calculator's set to that. But here I'm asking for 0.99. Right, then I'm going to scroll down to calculate, and I'm going to hit enter. And you should see something that looks like this. Okay. So what we're saying here is it's 0.262 or 263 when I round it all the way to 0.337. Sorry about that. So if it helps to see it, we're saying it's somewhere between 26.3% all the way to 33.7%. Okay, so what this means, the way I would interpret it is based on this sample. We are 99% confident that the proportion of adults who will attend a baseball game before a vaccine is between, so the real value is somewhere between 26.3% and 33.7%. All right. That's listed as a percentage. You should probably just write it actually as 0.263 to 0.337. And that's how you do these confidence intervals for a proportion. So when you go to write this on your quiz next week, I just want to see this right here. Right? Pretty straightforward, at least using the calculator.
Yeah, easier.
Calculator's always easier. All right, so what I'll do now is I'm gonna stop the lecture, and before I do stop the recording, I just want to say that actually, if your quiz this week is 4 questions. 3 of the questions involve just calculating confidence intervals, so you could actually answer 3 of them right now. Question number 3 on the quiz is going to involve you watching the lectures that I've posted to kind of get an understanding of how to do the problems. Okay.
Which numbers?
Question you can do right now on the quiz.
Oh.
I'll load it up and show you. You could do questions number 1, questions number 2, and questions number 4.
Okay.
Question number 3, you'll probably have to watch the videos to kind of understand exactly what I'm asking you to find in that one.
Okay.
All right.